What's up guys, I am here to explain leetcode question number 2641 cousins in binary tree 2. So in this question we have been given a binary tree and what we need to do is we have to replace every node with the sum of its cousins. So here what does cousin mean? So here cousin means that any node which is at the same level but belongs to a different parent. For example, this 10 has cousin as 7 because both are at the same level, which is level 3, and both have different parents. For example, for 10 it's 4 and 7 it's 9, but 10 and 1 are not cousins because they have the same parent. Similarly, 9 and 4 are not cousins because they have the same parent. 10 and 9, these are not cousins because they are not at the same level. Okay, so what we need to do is we have to replace the value with sum of all the cousins. So here for 1 the answer will be 7 because there is only one cousin, so the sum will be 7. Similarly for 10 it's going to be 7, but for 7 1 and 10 both are cousins, so the answer will be 1 plus 10 11. Okay, here in the case of 4 there is no cousin for 4, so the answer will be 0. Similarly for 9, similarly for 5. This is how it's going to be solved. Okay, so now how to approach for this problem. Okay, what we can do is we can perform a level order traversal, which is also done through BFS. I hope you know about level order traversal. What we basically do is we traverse layer by layer. For example, I have also prepared this sample tree for you to explain my point. Okay, so what we do is we traverse like this. First we go through level 1, then we go through level 2, then we go through level 3, and finally we go to level 4. This is how we do. So now what we are going to do is, right, first at each level we will keep track of the parents of each node, right? For 4 it's 3, for 1 it's 3. Okay, now what we will do is while we are traversing we will store the total sum of all the children of these parents, right? For example, in this layer the sum for 3 will be 4 plus 1 5. Okay, and also on the way we are going to keep track of the total sum of all these nodes, which is also 5. Okay, now for each node what we are going to do is we will replace this value with the total sum of all these nodes minus the sum of the values of the nodes for its own parent. That's how we can get the answer, right? So in the case of 4 the answer will be total minus 5. So it will be replaced with 0. Similarly this will be replaced with 0. Similarly 3 will also get replaced with 0 because for 3 the parent is no one, right? So this value will be 0, and this value will be 3, and this total will also be 3, so answer will be 3 minus 3 0. Okay, now let's take the example for the third layer. Okay, it might get tricky. No, let's take the example for layer number 4 itself. Okay, let me make one more node here so that I can explain you better. Yep, here you go. Okay, let's start with layer number 4. Okay, so for 2 and 6 the parent is 2. Okay, address of this node, right? For 4 it's 5, for this 6 the parent is 6. Okay, let's call this node A, let's call this node B, let's call this node C. Okay, so here as we are traversing from left to right, what we will do is we'll keep track of the sum of all the nodes which are children for these nodes, right? So one thing that we will track this is for A the sum is going to be 2 plus 6 8. Okay, for B the sum is going to be only and only 4. Great. For C the sum is going to be 6. Okay, also we'll track total sum, which is 2 plus 6 plus 4 plus 6, which is 10 18. Total is equal to 12, 18. Okay. Now for each node, what will be the replaced value? Okay, you might wonder. So for 2, the replaced value will be sum of all the cousins, right, as it's mentioned in this question. So it will be 4 plus 6, because 4 and 6 are its cousins and 6 is not its cousin, right? So how can we get this total, right? We can get this through the total of all these values minus the sum for the parent of 2, which is 8, right? So our answer will be 18 minus 8, it will be 10, right? So 2 will be replaced with 10. Similarly 6 will also get replaced with the 10. 4 will be replaced with 18 minus the sum of b, which is 4. So it will be replaced with 6, 12, 14. So here it will be replaced with 14 and here it will be replaced with 12. Okay, because all these are its cousins, so what we'll do is we'll just do 18 minus c, which is 6, so it's 12, right? So this is how it's going to be replaced. Same for this layer, same for this layer, and same for this layer. So now time complexity, let's discuss time complexity here, right? Here we are moving layer by layer, right? Just a second. Here we are moving layer by layer. Okay, so here we are moving layer by layer, but we are only encountering every node once. Here it's 3, here it's 4, 1, here it's 2, 5, 6, here it's 2, 6, 4, 6. Okay, so we are iterating n times, where n is number of nodes in the tree, so the time complexity is going to be big O of n. Also space complexity, I'll tell you once I implement this. Okay, so here we are implementing level order traversal, which is done with the use of breadth first search. Okay, if you want, you can learn this concept. Let's begin implementation. Okay, first what we need is we need a queue, because we are implementing BFS, breadth first search, and it requires queue all the time. And this queue will contain tree node. Okay, now but yeah, also one thing, we also need to pass on the parent of that node, right? For example, we, in the case of 4, we need to pass on this node also, because this 5 is the parent of 4, right? So we are going to make a queue of pair of integers. Oh, so now initially we don't have any parent for this node, right, which is the root node. So we'll just put on parent as null here. So we'll q dot push, the pair will be null and then node. Okay, yep. Now we are going to implement level order traversal. Let's begin the implementation. Okay, here we need to store the total sum for each parent, right? Here as you can see, for the sum will be 2 plus 5, and for this one the sum will be 6, right? And in this way there will be so many values for each parent, right? So what we do is we maintain an unordered map. and an integer which will store the sum for that parent, the child of that parent. Okay, sum for parent, right? This will be the name. Okay. Good. Right, now this is how level order traversal is done. Okay, we are going to pass this pair. Q dot pop. Oh, right. Also for each layer we have to keep track of the sum of all the nodes in that layer, right? So it will be stored in layer sum equals to 0, initialized with 0. Sum and just add this node to. Okay, done. Also for that parent we have to add on this value as the sum for parent, right? So here we'll just add that. Done. Okay, so this is how it's done. But also we have to also traverse through all the nodes once again, right? In one traversal we'll just keep track of all these values, right? We will maintain all these values. Then in the next traversal we are going to update the values. For that we have to for that we have to store all these nodes in order, or also not in order. The order doesn't matter here. So let's store okay. I thought there was some call, sorry. Layer, it will be just called layer. We'll just store this, we'll just keep pushing back all these nodes into that layer vector. Done. Now for all the nodes in the layer we will update the value. Okay, node value will be total sum minus the sum for that parent. Layer sum minus sum for parent, for that parent node. Done. Oh, sorry, yeah, here it will not be sum, it will be layer sum. Okay, so it's done. And then in the end we just return the root as we have updated all the values. Okay, let's check our code once again. Okay, 5. Okay. Everything seems right. Let's check and hope for the best. Oh, I did a blunder. Here in this vector layer we also have to keep track of the parent for each node of that layer, right? So here we have to pass an array. Here we have to make a pair. Okay, now we'll pass cool. And then no value. Okay, yep, it's done, hopefully. Okay, I think there is some issue. The thing is that the values are not getting updated. Oh, okay, that's because we are not pushing back. We did some mistake in the level order traversal. Okay, if the left children of that node exist, we will push that node, making the current node as the parent and the left node as the child. Okay, similarly for right. Okay, yep, I think the case is correct. Let's make some of our own cases, like making a really big tree and just putting some null values here and there to make the tree a bit unique so that it can cover up all the edge cases. Yep, I think our answer is correct. Let's submit. We'll just go through the solution once again in brief, right, in case you missed something. Yep, it got accepted. Let's go through the solution again. Okay, what we are doing here is, let me explain you again. Right. At each layer we are going through the layer twice. For example, if we take the example for this, okay, this is our node A, this is our node B. Let's suppose, okay, we are going through this layer. Okay, so for the first traversal through this layer, we are just keeping track of the total sum of that layer. Okay, and the sum of all the nodes for each parent of these nodes, right? So in the first traversal, what we will cover is the sum for this node A, right? A, it will be 2 plus 5 7, and for B it's 6. Okay, in the next traversal, what we will do is also, my bad, in this first traversal we are also storing these into a vector so that we can access these once again. Okay, this will be called as vector layer. Okay, we are storing the nodes and their parents. Okay, in the second iteration we will use this vector. Okay, and just update the values of these nodes with total sum minus sum of the parents. Okay, so minus sum for A, for example, in case of 2 and 5, and for 6 it's total sum minus sum of B, right? And then we just update the nodes and move on to our next layer. This is how it's done. Now here time complexity is going to be linear, right, because we are just going through each node once, twice. So time complexity will be 2n, which means it's linear. Also space complexity here, it seems to be linear, right? It's linear. We are not using any 2D vectors, we are not using any two-dimensional memory. It's just everything is linear here. Okay, also we are not doing any recursion, so there is no call stack to worry about, right? So here is my solution. I hope you like it. Okay, thank you very much and see you with the next solution. Bye.